In our previous video, we have learned how to derive the equations for velocity in terms of time and in terms of displacement, accelerations in terms of time and in terms of displacement, and also energy in terms of time and in terms of displacement. We have also learned how to use them according to the situations given. So today we're going to look at how are we going to form the graph based on the information given, and also how to extract the information from the graph. Before that, let us go through a few basic shapes that we're going to use frequently in our sketching. First, if you're given sine omega t, then we're going to use the regular graph of sine. And if you have negative sine omega t, then we're going to use a graph of inverse sine. If you're given cos omega t in your equations, then you're going to sketch the graph of cosine. And if you have negative cos omega t, then you're going to sketch a graph of inverse cosine. So these four types of graph is a graph that we're going to use in our sketching. The first graph that we're going to look at is a displacement against times graph, okay? X against t graph. So let us start from the equations from the graph without initial phase angle first. Then how are we going to sketch a graph then? As usual, we are going to start from the general equations. So the general equations of a displacement, if an object starts to move from its equilibrium position, is x equals to a sine omega t. So if you look at these equations, you have the functions in terms of sine, a sine functions. Therefore, the graph is just a graph of sine, the normal graph of sine. So after you sketch the graph, and of course, remember, don't forget to label the axis. Okay, so you have x as the y-axis and t as the x-axis. And one thing that is very important is you must include their unit. Okay, depends on the question. Sometimes you might use meter, sometimes you might use cm, and times usually is in second. Then the other information that you must include in your sketching is the amplitude, positive amplitude and negative amplitude, and also period, the time taken to complete one cycle. So after you sketch one cycle, you label time, okay, capital letter T, the time taken to complete one cycle. So what if your object, it does not start to move from equilibrium? What if it starts from amplitude? For example, now you have a pendulum bob, okay, a pendulum. So you displace it, okay, until it is at a certain height from the equilibrium position. So this is your x equals to 0. So you displace it until say certain height. So the point where you release the object, this is what we call amplitude. So if you release the object from amplitude, then you're going to get a cosine graph. So x is equals to a cos omega t. Now, if you look at the equation, you have a cosine function. Okay, if you have a cosine function, then you just use a graph of cosine. So after you sketch the graph of cosine, basically you just label everything as usual. The axis together with its unit, and then amplitude, positive, negative amplitude, and also the time taken to complete one cycle, the period of the graph. Second types of graph that we're going to look at is the velocity against time graph, which is a v against t graph. So as usual, in order to sketch a graph, we are going to start from the general equations. Now, what if you don't have the equations for v? What if the question just gives you the equations of x? Basically, you just have to differentiate it, like what we did in our previous video. So v is equals to dx over dt. Okay, then you differentiate it and you put in the values that it given by the questions. Now, if you are given x in terms of a sine functions, then after you differentiate it, you're going to get v in terms of cos function. So v equals to a omega cos omega t. Now you have a cos functions here, so the graph would be just a graph of cosine. So after you sketch the graph of cosine, remember to label the axis with its unit, the axis with its unit. Okay, now one thing that I want you to keep in your mind. For xt graph, maximum values On the y-axis, we call it amplitude. But for VT graph, it is no longer amplitude. Okay, we are going to look at velocity amplitude, which is A omega now. Okay, it is not A anymore, but it is A omega and negative A omega. This is very important. So the maximum V, okay, V max is equals to A omega. Now, what if you have x in terms of sine, in terms of cos, sorry. So if you have x in terms of cos, after you differentiate it, you're going to get V in terms of negative sine. Remember, if you differentiate sine, you get cos. If you differentiate cos, you obtain negative sine. So if you have x equals to A cos omega t, after you differentiate it, it will give you V equals to negative A omega sine omega t. Now, if you look at these equations carefully, now you have a negative here and you have a sine here. So meaning that this is a negative sine function. So if you have a negative sine function, then what are you going to do? What are you going to do? You are going to sketch the graph of inverse sine. Okay, so you just flip the normal sine over, then you will get an inverse sine graph. After you sketch the graph, as usual, label the axis with unit, and then label the maximum value, which is A omega, and the negative A omega in your graph, and also the period in the graph. It is a must, okay, the time taken to complete one cycle. So that is the VT graph. Next, we're going to look at AT graph, A against time graph. As usual, we are going to start off from the general equations. And once again, if you are not given A, for example, if you are given X, then you calculate V by using dx over dt first. And then you differentiate V in terms of time to get an equation for A. So A equals to dV over dt. Now let's continue from the previous slide. Previous slide, you have V in terms of cos. After you differentiate it, what are you going to get? You're going to get negative sine function. So you have A equals to negative A omega sine omega t. So if you look at the equations, you have a negative here, you have a sine here. So this is a negative sine function. Okay, negative sine function. So again, if you have a negative sine function, then you use inverse sine graph. So A with the unit, T with the unit. And now if you look at the maximum value, the maximum value is no longer A omega, but it is A omega squared, the first part of the equations. Okay, this is the maximum value for A. So this is your negative A omega, right? So the reason it is maximum value, you assume sine omega t equals to 1. Okay, now what if you have V in terms of a sine function? So after you differentiate it, A would be equals to negative A omega squared cos omega t. So in previous slide, we have V equals to negative A omega sine omega t, right? So you differentiate sine, you get cos, so you keep the negative. So when you look at these equations, now you have a negative here, you have cos here. So when you combine it together, this is actually a negative cos function. Okay, so you have a negative cos function, then the graph would be inverse cos graph. Okay, the graph of inverse cos. So label the axis as usual with its unit and label the maximum value as A omega squared. Okay, and a negative A omega squared. And of course, don't forget the period. It is a must. So that's all for AT graph. So how are we going to sketch graph? Like the one that I showed you previously, or the one that comes with an initial phase angle? Well, as usual, we are going to start off from the comparing general equations with the equations given. So if the equations given is an equations without initial phase angles, then you just have to compare with one of these equations. See which one is relevant. Okay, whether it's x, v or a, whether it is a sine or a cos functions given, or sometimes you have to form the equation first before you sketch graph. Then you have to see which types of graph or which type of equations that you're going to use in your equations. So after you compare the equations given with the informations given or with the equations given, then you try to identify these following items. First, the amplitude. Okay, so for X graph, we are trying to identify the amplitude, but for V graph, what are we going to do? We are going to identify its A omega, whereas for A graph, we will try to identify A omega squared. Okay, and then after you identify the maximum value or the amplitude of the graph, the amplitude velocity, the amplitude accelerations, or just the amplitude, you then try to identify the angular frequency. So where is the angular frequency in your equations? It is located at here. You have omega, omega, omega. So this is the things that you need. Okay, this is the things that you need. Why? Well, like I told you before, now we have W, F, and T. These three terms, they are one big family. So in your graph, you must include the period, the time taken to complete oscillations, meaning that T is a must in your graph. Therefore, you are going to need the omega to calculate the values for period. So after you identify the angular frequency and there's no phase angle, then that is it. Okay, we have enough information to plot the graph. But what if you have initial phase angle? What if the questions come with initial phase angle? Then you have to modify the equations a little bit. So you have to change it to A sine omega t plus minus phi, and then A omega cos omega t plus minus phi, and then negative A omega square sine omega t plus minus phi. Okay, so this is the equations that you have to use as a general equations when the questions give you initial phase angle. Or sometimes the questions, it won't mention whether it starts from, it has an initial phase angle or not. It will just tells you, you pose the object up to a certain displacement and then you release it. That means the object starts from non-equilibrium positions. So meaning that it comes with an initial phase angle. Okay, sometimes you can straight away apply cos graph if the difference is 90 degrees, if you start from the maximum angle, but sometimes it is not. Sometimes the questions might give you an initial phase angle that is less than pi over 2 radian. Then you have to stick to these three equations. Okay, so after you identify the initial phase angles, then you determine the period times by using, okay, this is what I told you just now, you need omega for period. Okay, so you calculate omega, you calculate period by using omega. So that is the step number 1. Compare with general equations. Try to identify what is the maximum values on the y-axis for your graph. Okay, the amplitude, amplitude velocity, amplitude accelerations, and then you determine the angular frequency in order to calculate the periods of the graph, the time taken to complete one cycles, and try to see whether there's an initial phase angle or not. If there is, then you have to take into considerations the values of initial phase angle. Whereas other than these three equations, of course you can have an equations, okay, with cos, but just plus minus phi. Okay, what you can do, you just plus minus phi at the end. Plus minus phi. None. Okay, so you choose either one of these equations and then try to extract the information needed in your graph. Alright, so now that you have all of the information needed, what are you going to do next? Well, you want to sketch a graph, so of course you are going to need a y and x axis. So step number two, draw the y and x axis with the proper value and also units. So your y and x axis must come with unit. And what does it mean by the proper value? What does it mean by proper value? Well, just now we have identified A and we have also identified the period, right? So let's see how are we going to include it in our graph. So let's say now you are given some equations. X equals to A sine omega t. So what are you going to do? So you plot a graph with the y-axis as the x Now let's say if you are given x in cm, so you put a cm here, and then you have the x-axis is the time. Usually time is in terms of second. So after you label the axis with its unit, okay, you can write down the values for amplitude. So since you have an x graph, so my amplitude is just a plus minus a. So if you have a graph without initial phase angle, you can then write down the period. But if you have a graph that comes with initial phase angle, okay, then you cannot, okay, you don't write it down first. Okay, you don't write it down first if you have an initial phase angle. Okay, we leave it to step 5 if there's an initial phase angle. If no, you can write it down. After you label the axis, next step, you try to see whether you are given, say, cos functions or sine functions. So if you are given the sine functions, you also have to see whether you have positive sine or negative sine. Okay, and if you are given cos, you have to see whether you have a positive cos functions or a negative cos functions, because they all come with different shapes. Okay, the lines, the graph, they are different. So step number 3, you sketch the graph. So do you still remember what is the shape for these 4 functions? If you have a positive sign, then this is the shape of the graph. If you have a negative sign, then this is the shape of the graph. Positive cos, this. Negative cos, like this. Okay, inverse functions. So if the graph, okay, if you're given sine function, then the graph, it must start from 0. So if you're given cos function, then it starts from amplitude. So how do you know whether it is a positive sign or a negative sign? Sometimes you're not given the equations, right? So you look at the questions. The questions tells you the initial positions of the object. If it says your object starts from equilibrium positions and then it moves to the right hand side, okay, it moves towards right hand side first, meaning that it is moving towards positive x direction. So in this case, what do we have? We have positive sign. Now, if it tells you the object is being displaced to the left, okay, then you are going to have negative x, right? Meaning that in this case, okay, your object, we're going to have a negative sine functions, okay, because it's being displaced to the left. Now, how about cosine? Now, it tells you the object starts from amplitude. So amplitude, you can have a positive amplitude and a negative amplitude. If you have positive amplitude, means you are start from the right hand side, you release the objects from the right hand side, then it would be a positive cos function. If you release the objects from the left hand side, meaning that you release it from the negative amplitude, then you're going to have a negative cos function. Alright, so after you identify which types of functions that you're having, then you can sketch the graph. So if you have just a normal graph, you move the object to the right, then you just put a positive sine graph. Okay, the graph of sine in your axis. So we're just going to look at the general case. So if you have a positive cos, then you just put a cos graph, okay, the graph of cos in your axis. So this is if you have positive sine and positive cos. So if your graph, it doesn't come with initial phase angle, then you can stop at step number 3. But what if you are given a graph with an initial phase angle? For example, now you are given a graph, let's say x equals to a sine omega t. Let's say if you have an initial phase angle pi over 2. So what are you going to do? So you are going to shift the graph. So how to shift the graph? There's a rules for you to follow. So this is a rules to use when you want to shift graph. If you have positive initial phase angle, you can choose either to shift the y-axis or to shift the graph. You have 2 methods. Okay, and I'm going to show you both now. So we have initial phase angle equals to pi over 2 radian. Okay, so let's take the equations above as our example. So when you reach step number 3, this is the shape of the graph that you're going to use. Okay, you have x here in terms of a cm, and then you have a t here in terms of a s. According to the questions, you have a sine graph, a positive sine graph. So you just put the graph of sine here. So I'm not going to label A in my diagram first, because when I shift the graph, the A will move as well. So what am I going to do now? I'm going to shift the graph. Now you pay attention to what happens to this y-axis. Okay, but before that, now let's see. You have initial phase angle equals to pi over 2 radian, right? So this is actually equivalent to 1 over 4 revolution. So meaning that you want to shift this y-axis by 1 over 4 revolutions of the graph. So one whole graph is equals to 2 pi. Okay, meaning that you want to shift the graph. Okay, you want to shift the graph until it reaches here. So let's see how you're going to shift it. So you move it. Aha, now you have the new y-axis here, the new positions for y-axis. And based on the diagram, this is your pi over 2 radian. Okay, or we call this equals to 1 over 4 revolutions as well. Okay, so they are equivalent. So you move this by 1 over 4 revolutions already, and after you move it, remember to erase this line, okay? Because in our graph, it is impossible for us to have negative time. We won't have negative times in our real life. Okay, if you find a way to get the negative times, you let me know so that I can get younger, I can become younger. Right now, if you look at the right-hand sides of the graph, what are you going to do? Now, if you look at the graph, well, the graph, it is not enough to form one cycles, right? So if you don't have a length for one cycles, if it doesn't complete one revolutions, then you cannot label period in your graph. So what I'm going to do next is to extrapolate the graph so that it completes one revolutions. Then you can label the period in your graph. So this is what you have to do. Okay, so step 4, you shift it. Step 5, you complete the rest of the things. So for example, you complete the A, you write down the A minus A, and then you write down the period. And make sure it is always one revolutions. Well, sometimes it depends on the questions, okay? Questions might ask you to sketch a graph for in between 0t until 1 period. It might ask you to sketch for times in between 0 until 2t or 3t and so on. Then you just have to keep going on. If 2t means the question is asking for 2 revolutions, 3t means the question is asking for 3 revolutions. Right, next. So after you've done this, okay, it's done. But what if you don't want to shift the y-axis? You want to shift the graph. Then what should you do? Okay, now let's see how I'm going to shift the graph. So what does it mean by graph? This red color line is the graph. Okay, this red color line is what we call graph. So now you don't want to shift the y-axis, you want to shift the graph. So what are you going to do? Okay, now look at what happens to this graph here. Okay, I'm going to shift it now. So according to the table, if I have a positive initial phase angle, I'm going to shift the graph to the left. So I'm going to move this whole graph to the left. Now I move it. Okay, I move it by pi over 2 radian as well. Okay, this is also 1 over 4 revolutions. So after I move the graph, as you can see now, same things happens to my graph. Now on the right hand side, it doesn't have a 1 complete cycles anymore. So you extrapolate it, okay, extrapolate it, and then you label period. And then this part, again, you erase it. Okay, and remember to complete the graph with all of the labels, the values that you can put, the units that you should put, and so on. Okay, so that is how you sketch graph. That is a complete recipe for you to sketch a graph. Now, sometimes students will ask me, if they don't want to use this step 4, is it okay? Well, of course you can, because sometimes students, they know how does the graph looks like by just looking at these equations. Okay, if you know that, okay, if you notice s equals to a sine omega t plus pi over 2 radian, actually it is equivalent to x equals to a cos omega t. Then of course you can straight away you can plot the graph of cos. Okay, you don't have to follow this 4-step recipe. This 4-step recipe is for those who still not quite familiar with the sine functions, who are still not quite familiar with what does it mean by pi over 2 radians and so on. And sometimes the questions might not give you pi over 2 radian, then you might need to use this 4-step to sketch the graph. Okay. Now let's try an example. See how are we going to apply that 4 equations in our questions. So examples 1. Sketch the x against t graph for the following expressions. X equals to 2 cm. Now, as you can see, you have an x in terms of cm now, and sine 2 pi t, that is omega t, plus pi over 2. So this is an equation that comes with an initial phase angle. Okay, so you have initial phase angles equals to pi over 2. So how are you going to sketch it? So give yourself 2 minutes, pause this video, try this question first. See whether you can get answer or not. Alright? So if you sketch it correctly, this is what you're going to get. So this is the answer, okay, if you got it correctly. So I'm going to go through the 4 steps with you quickly. So step 1, compare with the general equations. So you are given x equals to 2 cm sine 2 pi t plus pi over 2. This is an equation with initial phase angle. So what are you going to do? You're going to compare with the general equations with initial phase angle. So you have a omega t plus phi here. I use a plus sign here because the initial phase angle given is a positive initial phase angle. So after I compare it, okay, I'm going to get A equals to 2 cm, and then omega is equals to 2 pi radian per second. The reasons why we want to determine omega, why we need an omega, is because we want to calculate period. So period is equals to 2 pi over omega, which is equals to 1 second. And then according to the questions, initial phase angle is a positive value, a positive pi over 2 radian. And remember, pi over 2 radian is equals to 1 over 4 revolutions. Okay, so step number 2, draw the y and x axis with proper values and unit. So according to the questions, you have an equation in terms of time. The displacement given is in terms of time. So we are going to sketch an x against t graph. Okay, meaning that your x depends on t, or x changes with t, because the equations given is in terms of time. So x, the unit is cm. How do I know it's in cm? Because amplitude given is in terms of cm. So time is in second. Okay, so after you have the graph, you plot the axis with unit, and then you label the value 2 and negative 2, which is the accelerations of the graph. Then the period, I'm not going to put it down first because I have to shift the graph after this. So I'm going to keep period as my last step. So step number 3, you sketch the sine functions. So given the functions is in terms of given the equations is in terms of sine functions, and you don't have to look at the initial phase angles yet in your step number 3. You're just going to sketch the general shapes, okay, based on the functions used in the questions. So you have a sine functions, therefore you just put the graph of sine in your axis first. Then we'll proceed to step number 4. So step number 4, we are going to shift the graph according to the initial phase angle. So according to these questions, initial phase angle given is positive pi over 2 radian, which is equals to 1 over 4 revolutions. And since this is a positive initial phase angles, then you can decide whether you want to shift the y-axis to the right or you want to shift the graph to the left. And personally for me, I like to shift y-axis because positive means right-hand side, negative means left-hand side. The concept is same as the concept in vector. So I shift the y-axis to the right, and I'm going to get a graph like this. So if you still remember, like I told you in the previous slide, so when you have a graph like this, after you shift the axis, what are you going to do? You are going to remove the part on the negative time, okay? Because it is impossible for you to get a negative t, so don't have any line in terms of in the negative t sections, okay, on the negative t side. Then you look at the remaining line, okay, the remaining graph. The remaining graph is not enough to form one complete revolutions, one complete cycle. So what are you going to do? You're going to extrapolate the line, extend the line until it reaches 1 revolutions. Okay, so after you extend it, you extrapolate it. This is the period. Okay, this is a period. So this is the complete graph for questions, this example. So now let's see what is the answer. So your answer is like this, okay? So on the left hand side, I put a dotted line because this is the part that I remove. Okay, the reasons why I remove it, because it is impossible to give negative p in your actual situations. And then the part that I added becomes a solid line, okay? So the reasons why I add this part is so that I have enough graph, I have the lines, okay, that is enough to form one revolutions or one cycle. Okay, so this is the whole graph. So that is how you apply the 4 steps recipe in answering the graph questions, in graph sketching questions. Okay. So in this slide, we're going to see what is the relationship between xt, vt, and at graph, and how are we going to transform emotions into a graph. So this is a diagram of a simple pendulum. We're going to analyze the motions of a simple pendulums, okay, in this slide. So first, let's see what happens at point O. So at point O, the object is said to be at equilibrium position. Okay, equilibrium position. And then at point A and point B, okay, point B is said to be at positive amplitude. So this is the amplitude. And point A is also the amplitude, but it is a negative amplitude. Okay, so the reasons why it is a negative amplitude, because it is on the left hand side of the object. Positive because it is on the right hand side of the object. Okay, now before we analyze the graph, let's go through a few terms. So in this case, the things I'm going to look at is a h. Okay, h represents the height of the object. So when the object is at its lowest point, I'm going to assume h is equals to 0. Okay, so if it's located at point B, then this will be the h, the maximum height. Okay, this is the way I determine h. Okay, this is a maximum height. So h max. And then if your object is located at point B, then how are we going to determine the x? Remember, x is the displacement from the equilibrium positions. And if given the angles between the original positions and point B is very small, then this line seems to be a straight line. Okay, the curve that is moving by the object from O to B, actually it can be treated as a straight line. So this would be your displacement, your x. Okay, provided angle is very small, it is less than 10 degrees, like we discussed in our lab before. So now you have x here, you have a h here, and then you have a h equals to 0 here, and then your theta is very small. So let's see what happens to the energy of the object. Okay, so why do I want to look at it in terms of energy, so that we can see what happens to its velocity. So when the object is at equilibrium position, your h is equals to 0. So when h equals to 0, we take u equals to 0, right? Because h equals to 0. Now, when your h increase, okay, when the object moves until point B, your h is at maximum value. So if you have h equals to a maximum value, then the u is also at its maximum value. Okay, so what happens to the kinetic energy? Now, if you recall, what have you been doing in chapter 2? We take maximum height, the v is equals to 0. Why? Because it is a turning point. Object stop for a moment, for a very short period before it changes its direction. Okay, so we assume v is equals to 0. We take v is equals to 0 at a maximum height, and therefore k is equals to 0. Okay, so according to the principle of conservation of energy, summations E is equals to k plus u. K plus u, okay? And if there's no energy loss, then it is always equals to a constant value. So meaning that when the object moving from B goes back to O, okay, the energy is being transformed from U into K. So when it reaches the lowest point, okay, your U is equals to 0. That means that all of the energy has been transformed into K. So you have Kmax at the lowest positions, at the equilibrium positions, and this Kmax, it tells you that you have maximum velocity at the lowest point. Okay, you have a maximum velocity at the lowest point. So it keeps moving on, keeps going on until it reaches point A. Your K goes back to 0 because of V equals to 0 at the highest positions, at the tallest point, at the turning point, and your U, it goes back to a maximum value. Why? Because H is maximum. Okay, so when H is maximum, your X is also maximum. Okay, this one is also maximum. That's why we call it amplitude. So now let's see, how are we going to interpret these motions? How are we going to change it into a graph? Okay, so let's look at a graph of a displacement against time. For displacement against time, okay, if O is moving, object start from O and it moves towards B, okay, so it's moved to the right hand side. So on the right hand side we have positive X, therefore my graph is heading towards positive A. So in this case I have this graph of sine because O is moving towards positive direction, therefore I have a graph that's going up and eventually it will form a sine graph. So when it reaches point B, which is the highest point, maximum displacement, then we have a positive amplitude. So positive amplitude means your X is maximum, okay, maximum displacement. Then how about VT graph? Now VT graph, the object starts from equilibrium position. So since the angle is very small, okay, so even though it's moving in a curve, we can treat it as a straight line. So we say object moving to the right. So if you still remember, V depends on motion. Okay, V depends on motion. So if the object is going to the right, then you are going to get a positive V. If the object is heading to the left, then you are going to get a negative V. So in this case, if my object is moving towards B, means it's going to the right. Therefore, I start from maximum velocity, okay? The velocity amplitude, the maximum velocity. So I have Vmax is a positive value because now it is going to the right. Okay, so when it goes towards B, the velocity will decrease. Okay, why it decrease? Why it's slowing down? Because of the restoring force. Okay, so as the object goes towards B, the restoring force will try to pull it back to its original positions. Therefore, it slows down. So it decreases, and when it reaches the maximum height, which is point B, it stops for a moment. Therefore, V is equals to 0 at point B. Then how about A? Well, if you still remember, in our previous lessons, we have derived equations for A, and then we know that A is directly proportional to negative X. Meaning that A will increase with X. Why? Well, it makes sense. As your objects getting further away from the equilibrium positions, the restoring force will increase. So if restoring force increase, definitely accelerations will increase, right? But then how about this negative? Negative, it just tells you that the directions of A and the directions of X, they are always opposite to each other. Why? Because when an object is located on the left-hand side of the original positions, of the equilibrium positions, the force, the restoring force will always try to pull the object towards the negative side. Okay, so you have right-hand side as a positive X. So whenever your objects, they are located on the right-hand side, it doesn't matter whether it's heading towards B or it is heading towards O. As long as it has a positive X, then the restoring force will always be pointing to the left. This is your restoring force. So they are always opposite in direction. Therefore, when you sketch graph, okay, when it gets further away from the O, when it moves towards B, the magnitude increase. Okay, but it increased in the negative direction. Why? Because this negative, it represents direction. Okay, it just represents direction. So it has nothing to do with the magnitude. Magnitude is okay, it's increasing. Okay, but direction is opposite to the X. Okay, x is on the positive side, therefore you have negative a. So when you reach the maximum point, of course it will have a maximum restoring force, therefore you will also have a maximum amplitude here, maximum accelerations. Okay, accelerations amplitude at point B is maximum. So as object move from B towards O, okay, after it stops and it goes back towards O, what happened? So in the xt graph, okay, it will decrease and until it reaches point O. Then how about velocity? Now velocity after it reached the maximum point, it stopped for a moment, and then when it goes back towards O, it changes its direction. Okay, so now it's moving to the left. Therefore, you have a negative velocity here. And it's getting faster and as it moves towards O, as it gets closer to O. Why? Because the kinetic energy increased. Therefore, it's moving at a highest speed. Okay, and also it's moved towards the directions of restoring force. So of course it will get faster. So when it reaches point O, okay, now you have the maximum kinetic energy again. Therefore, you have a maximum velocity. But now if you look at the graph, both initial point and final point, they are located at O, right? Now initially you have a maximum velocity where it's located at O, but it is a positive value. But when it goes back to O, okay, after it goes to B and it goes back to O, now you have negative V. Why? Because of the direction. Just now your object is going to the right. Okay, so when it comes from V to the O, the direction is going to the left. Therefore, you have a negative sign here. Okay, negative velocity here because of the directions of motion. Okay, initially towards B is to the right, and then when from B it goes back towards O, it's heading to the left. So it is a negative value. And this is also one of the reasons why for the equations V, we have V equals to plus minus omega square root a square minus x square. Okay, so the plus minus sign here, it is because we have a same V, okay, same magnitudes of a same speed at the O, but they are heading towards different direction. So at the same positions, at the same displacement, it could be a positive value and it could be a negative value. That's why for the equations of V, this is the only equations that come with a plus minus sign. There are two possibilities, depends on the directions of motions. Then how about A? So after it reaches the maximum height, okay, maximum displacement, okay, the accelerations will then decrease, okay, because the restoring force is getting smaller as it's heading back to its equilibrium position. So when it's go back to its equilibrium positions, of course, since it is at its equilibrium positions already, so there's no restoring force anymore. Therefore, A, it goes back to 0 at point O. Okay, because it's already at its original positions, equilibrium positions. So what do you need? The restoring force, right? Okay, so the object keeps moving towards A, so maximum displacement, okay, maximum negative, because now it is on the left-hand side of the original positions, of the reference position. So it is negative x, and then it goes back to the origin. So basically it's the same, okay, so it has a maximum speed, and then as it moves towards A, okay, it is still negative direction. Okay, it's still going to the left, so you still have a negative V, but now the speed decreases. Why? Because as the object passes the equilibrium positions, the restoring force will increase again. So when it reaches point A, the object stops for a moment before it keeps going on, okay, before it changes its direction. So after it reaches point A and changes directions, now you have positive V here. Okay, now you have positive V here. So the negative and positive V is because of the directions of motions. So when you reach point O again, now it's from O heading towards from A heading towards O. So you have positive direction. Therefore, now at point O, you have positive A omega instead of negative A omega like just now. Okay, now can you see the difference? It's because of the direction. From B to O is going to the left. From A to O is going to the right. Therefore, one you have a negative V maximum, one you have a positive V maximum. Then how about A? So when an object passes the equilibrium position, okay, is heading to the negative amplitude, negative displacement. So as you get more and more negative, A will become more and more positive, okay? Why? Because the restoring force increases again as it goes further away from the equilibrium positions. Until it reaches the maximum point, then you will have the maximum restoring force, which gives you maximum acceleration. Okay? So after that, it decreases again as it goes back to O. So when it reaches point O, once again, it goes back to 0. So basically, that is how you interpret the motions in terms of graph. Okay, you look at what happens to the object at every single position. You look at the directions of motions. Okay, you look at whether the object is on the left hand side, on the right hand side. You look at what happens to the restoring force before you change the motions into graph. Okay, so that's all for this slide. If you have any questions, you may ask in the class. So the next graph that we're going to learn is the energy displacement graph, okay? Take notes here, it's energy displacement, not energy time. So you have a E against X graph. But we're not just looking at E, okay, because we know E is equals to K plus U. So we're going to look at K against X graph, we are going to look at U against X graph, and we're going to look at E against X graph. We're going to see these three types of energy against displacement graph. Right? So well, since the questions give you displacement, means that you might have positive X and also negative X. So when it comes to energy displacement graph, your graph should have a positive and a negative axis. Okay, so the first graph that we're going to look at is a kinetic energy graph. Kinetic energy against displacement graph. So the equations for kinetic energy in terms of displacement, well, since you are going to look at the energy displacement graph, means that you are going to use energy in terms of displacement equations. So K equals to 1 over 2 m omega square bracket A square minus X square. Well, you don't really need these equations when it comes to a graph sketching. Why? Because you already know what happens at every single positions. Okay, what happens to the kinetic energy when it reaches the maximum positions? What happens to the kinetic energy when it is at its lowest position? Okay, so you don't really need these equations in a graph sketching, but you can use it to calculate in your calculations. Okay, you can use these equations to calculate the maximum kinetic energy. You can use it to calculate, maybe you can use it to calculate omega or m. Okay, because the information that you can get from the graph is the K and X, because now you're going to sketch a K against X graph. Okay, so this is a K against X graph. So if you can't remember the shape of the graph in the exam, or you truly have no idea how to draw it, then you can sketch a pendulums in your graph. Okay, you can put a pendulums, it lie on the y-axis, so this is a pendulum. Then you can start to imagine what happens when it swings to the right and what happens when it goes to the left. So when it reaches the maximum positions, which is the amplitude, okay, we know that object will stop for a moment, means that V equals to 0, right? So when V equals to 0, our K is also equals to 0. Therefore, our K is located at x-axis when we have X equals to amplitude. Or you can also apply these equations, okay? You can also apply these equations. So when your X is equals to A, okay, this part is equals to 0. Therefore, we have K is equals to 0. Right? So you have two methods that you can use to remember it. So usually I will go for the velocity one because it's easier to remember, and because we all know that objects stop at this turning point. Okay, it stops for a moment at its turning point. So when it goes back to the original position, since we take here as the lowest positions, or we say this at this equilibrium position, so therefore we have the maximum kinetic energy. So this is your K max. Okay, so this K max, it can also come from these equations, because when your X equals to 0, your K max is equals to 1 over 2 m omega square A. Okay, A square. So this is the maximum kinetic energy, because your A don't have to minus with anything. Okay, or you can even say, because at its equilibrium positions, your U is equals to 0, therefore K is maximum. Okay, and then you repeat the same thing for the negative A and see what is the value for kinetic energy when your object is located at negative amplitude. Then you can get a graph like this. Okay, it is a curved graph. It is a nice curved graph. Okay, so the next graph that we're going to look at is the potential's energy against displacement, Potential's energy against displacement graph. So we're going to write down the equations in terms of displacement again. Okay, and once again, we don't really need it in sketching our graph, but we might use it in our calculations. Why? Because again, we can get the values of u and x in a graph. So u equals to half m omega square x omega square, and this is the shape of the graph. Okay, so you have u against x graph. So again, if you can remember, once again, you can just sketch the pendulums on along the y-axis. Then you see what happens when it gets further away from the lowest point. Okay, so when the object is at the maximum height, or when x is equals to a, your u is equals to 1 over 2 m omega square a square. So this is the maximum values that you can get in a motions, okay, in an oscillation. So this is your u max. So when it's at its lowest position, since x is equals to 0, so straight away your u is equals to 0. Or you can also say because at the lowest point h is equals to 0, therefore your u is also equals to 0. So there are a few methods that you can use to determine the value at different positions. Alright? And the last graph that we're going to look at is the total energy. Okay, total energy in terms of displacement. So we have E equals to 1 over 2 Ka, and at the same time it is equals to 1 over 2 m omega square A square. So according to the principles of conservation of energy, we know that summations E is equals to K plus U if there's no energy loss. Okay, and it is always equals to a constant value. And also, if you look at these equations, this equation shows that energy, it does not depend on the displacement, and also it does not depend on the time. Okay, so when you sketch the graph, basically total energy is just a straight horizontal line. Okay, so this horizontal line, it shows you that the total E is always constant. Okay, and it doesn't depend on your displacement. Okay, so that's all in 9.2. If you have any questions, you may ask in the class, or you can WhatsApp me. Okay, you can WhatsApp me if you have any questions. So that's all for today.